All right, so you probably remember in electrochemistry we had a thing where we would find our strongest oxidizer and strongest reducer on a redox table, and if a line from the oxidizer to the reducer went in that direction, we would say that the reaction was spontaneous. And if the line from the oxidizer to the reducer went uphill, like so, we would say the reaction was non-spontaneous. Guess what? Acids and bases have the exact same thing with the exact same directions. So if you learned it once, this lesson will probably go fairly quickly for you. If we have a reaction such as this, methanoic acid added to CH3COOH. Now, let's see if I can actually find those on my table. Methanoic acid is here. It's also known as formic acid. And that's added to an ethanoate solution, or an acetate solution, which is right here. You can see from the direction that this reaction is going to be spontaneous. And so the reaction you would assume, which is HCOOH, that's methanoic acid, reacting with this, will go to the right, or the products will be favored. And we'll lose a hydrogen here, we'll gain a hydrogen here. And we can expect to get more products than reactants when we do this. Hydrochloric acid would be the next one, and I think this is going to be a quick one because hydrochloric is such a strong acid. Hydrochloric is up here, and really we should treat it like H3O, right? Because it dissociates as soon as you make it. And that's interacting with fluoride ions. That should be spontaneous again. So for this first one, we had, I'll say equilibrium right, or favors the right side. Here again, we get equilibrium to the right. What else have they got for us? H2SO3. Where are you? Oh, higher up, sorry. Tiny little table. Okay, that should be our strongest acid in this one, and that's react with H2PO4, which could be our base. Where is that? Sorry for the slowness. Here we are. Here's phosphoric acid. H2PO4 is right there. So this one's kind of close, but it is still downhill, so it is still spontaneous, or the equilibrium's to the right. Or you could say it favors the products, which is the same thing. And last one. Nitrous acid, which is HNO2, is combined with nitrate ions, which are NO3. Okay, so if we're looking for our strongest acid, HNO2 is there, that should be it. If we're looking for our strongest base, reading up, reading up, reading up, reading up, NO3 is right here, and that looks like it could be our strongest base, but don't forget, we always have water, and in this case, water is actually a better base than nitrate ions are. So the actual reaction in this one will be HNO2 combining with water, and that gives up a hydrogen, and we get nitrite ions. This gains a hydrogen and becomes hydronium ions, sorry. And this one, note well, is not spontaneous. This is like pushing a rock uphill. If HNO2 gives a hydrogen to H2O, the H2O goes, wait a minute, I'm suddenly a much stronger acid than you are. You take this back. And so even if by some miracle this did manage to hand off a hydrogen, it wouldn't stay handed off for long. The H3O would force it back the other way. So this reaction favors the reactants, or its equilibrium lies to the left. Good?